Pennypack Creek Microcosm, Shandra Seim, EVSP 416, General Ecology, Microcosm Project, 22 July 2023, Professor Gangloff. Overview. Collected from Pennypack Creek, this microcosm was created with the intention of learning how different organisms interact. I hoped to gain a better understanding of interspecies relationships within a community and the effects of their environment. Hypothesis. Of the specimens I collected from Pennypack Nature Preserve, I believe that the algae will be most prosperous. With that being said, I believe the algae will provide enough oxygen to support some continued animal life. I expect some of the organisms to perish, thus providing nutrients back to the remaining inhabitants of my microcosm. Methods and materials. My specimens were collected from Pennypack Creek. The image to the right is a map of the preserve with a red X indicating the approximate collection site. The elevation of the site is approximately 80.4 feet above sea level, and the GPS coordinates are roughly 40 north by 75 west. The container used to create my microcosm was a cylindrical storage jar from IKEA with dimensions of 12 centimeters by 12 centimeters by 21 centimeters and a volume of approximately 1005.5 milliliters. To transport plant matter, I used a ball mason jar with a volume of 473 milliliters. To collect the water and soil, I used a 1/4 cup McCormick measuring cup equal to around 59 milliliters. From Pennypack Creek, I collected roughly 235 milliliters of algae and grass, 125 milliliters of sediment, and 800 milliliters of water. When constructing the microcosm, I removed around 200 milliliters of the water to make room for the assorted flora, making the amount of water used for this project approximately 600 milliliters. Temperature range. The duration of this experiment was from 7 June 2023 to 19 July 2023. The weather was mostly sunny, although we did have smoke cover from the Canada wildfires. Temperatures ranged from a low of 47 degrees Fahrenheit at night to a high of 95 degrees Fahrenheit. Observations and data day 1. The day that my specimens were collected, the water was cloudy and tawny in color. I was able to observe a few small invertebrates swimming in the water as it settled. Observations and data week 1. At the end of the first week, the water was more transparent, having had time to settle. The algae was vibrantly green, which shone as a stark contrast to the brown grass I had collected. I observed a larger community of invertebrates than day 1 and spotted a small snail just above the waterline. Observations and data week 2. The second week was when I began to see some of my specimens dying off. There were still a plethora of invertebrates swimming in the microcosm, but a few had climbed above the waterline and appeared to be drying out. The grass also separated from the soil. Observations and data week 3. During week 3, I noticed that the air bubbles had begun forming on the top of the algae. More invertebrates had scaled above the waterline, and the water itself was getting darker. The snail was still above the waterline, but had moved since my last observation. Observations and data week 4. Condensation began to accumulate on the lid of my microcosm during the 4th week. The majority of invertebrates were now out of the water. I believe that at this point the grass was actively decomposing, adding to the darkened coloration of the water. The snail moved further up the container and positioned itself on the lid. Observations and data week 5. Everything appeared brown and dingy by week 5, save the algae. I no longer was able to observe anything swimming in the microcosm. The amount of air bubbles present in the algae had increased, as had the amount of condensation. Observations and data, week 6. Week 6, I noticed the snail was no longer moving and I could no longer see the grass in my microcosm. There was a slight yellowing around the dead invertebrates now, and everything had deepened in color again. The algae was still producing air bubbles, and condensation appeared to have increased slightly. Observations and data, week 7. My final observation was made in week 7, where I noticed everything had become so dark and clouded a light needed to be shown directly behind the microcosm to be able to see into it. The algae is producing less air bubbles and has deepened to a green that was much darker than the original shade, except for at the very top. Major findings. Over time, I found that my microcosm imploded. With it being a closed system, the non-renewable resources were unable to support life long term. I correctly suggested that the algae would thrive better than the other specimens and that the nutrients from the decaying flora and fauna would feed back into those surviving. But I was incorrect in hypothesizing that continued animal life would be supported by this environment for the duration of the experiment. Concepts depicted. Concept 1, biodiversity. Identifiable in this microcosm are 2 types of flora and at a minimum 2 types of fauna, the snail and the smaller invertebrates. Given that there is only one snail, the other small invertebrate species would be the dominant one. Concept 2, nutrient cycling. While we may not be able to visibly see the exact chemical breakdowns as decay happens or the uptake of the released nutrients, we can see the water deepening in color as a result of decomposition, returning nutrients to a usable state. Concept 3, competition. The algae and grass both require sunlight and nutrients from the water and soil and occupy similar niches. The competition in this case would be largely over the available sunlight. The algae had a large surface area and dwarfed the grass, keeping it from receiving enough sun to survive. The grass died off and the algae prevailed. Conclusion. Microcosm experiments are relevant to the study of ecology because they are a small-scale, manageable replication of a larger ecosystem. Observations made in microcosms can be applied to real-world circumstances to better understand interspecies relationships, biotic niches, species richness, and even how potential pollutants affect a population or a community as a whole. The controlled environment makes it possible to test theories without disrupting the majority of a community. Further research. In the future, I would be interested to see how different my results would be if I tweaked the components of my microcosm. I would like to attempt a similar experiment with different ratios of water, flora, and empty space. To improve upon this project, I would like to monitor the water temperatures for the duration, annotating them daily at a specified time. I would also like to create a scenario in which there was an area available for potential fauna to climb out of the water onto a pedestal of soil, creating an additional niche.